And they have a better way of viewing the molecules and the shapes. So we just did methane, CH4. We said that the bond angles are essentially 109.5 degrees away from each other. So you can see that they're perfectly spaced out around each other. And I can actually, in this video, start to rotate the molecule around. And you can see how they're equally spaced, how the vectors would cancel each other out in all the situations, and overall this molecule would be non-polar. With the ammonia molecule, very similar, the nitrogen being in blue and the hydrogens being in white, and we can rotate this around. Up on top, but it's not really shown well here, is the actual electrons, the lone pairs that would be sitting on top of the nitrogen, and that's the reason why these hydrogens are pushed down. So it may look like they're not there, but they actually are. And so the 3D shape of this is a pyramid. And lastly, we move on to water. The water molecule is it's got two lone pairs of electrons. It'd be situated one here on the left side and one here on the right side up above, forcing the hydrogens down below to get away. But the shape overall looks like this. Remember, these are just models. This is a ball and stick version of what we think this thing looks like. To get a better idea, what we can do is try to show the actual electrons around it, like the sphere that might be around it. And so what we can do is, in this little program I have, I can actually go and go to a space filling model, and this is most likely what the molecule looks like. This is the space where any of the electrons can be found. So in this area here, you would find the electrons around the hydrogen, and you can really see the oxygen. The electrons would mainly be around the oxygen. It would hog everything, and we get this large sort of globe situated out of it. And this is really what a water molecule would probably look like. And similarly with ammonia, there's our ball and stick model of it, with the nitrogen in the middle. And if we use the program to kind of estimate where the electron radius are, we can see this is probably more what it looks like. It almost looks like a huge sphere with little lobes sticking out where the hydrogens are. You can see that the nitrogen really hogs all the electrons. The hydrogens get very little, so that's why you get these little lobes sort of poking out. So you can see it's the nitrogen part of it that probably will deal with a lot of chemistry. The hydrogens themselves, each one of them can be involved in chemistry as well, because they just kind of stick out. And that's kind of what the molecule would look like. And finally we move on back to methane, and we do a space filling model of this. Same thing, the carbon hogs most of the electrons. You can see it's a very large molecule overall, it seems like, because of all the van der Waals radii that are in this. And see all the little hydrogens poking out.